Hi everyone, welcome to the Opamp Masterclass channel. Today we're going to discuss about the ideal Opamp characteristics. There are five ideal characteristics. One is that input current is zero, input offset voltage is zero, input impedance is infinity, output impedance is zero, gain which is infinity. Let us understand an op-amp with two signals, input signals V1 and V2, and one is at the positive terminal, negative terminal, and this is the output of the op-amp. It is also connected to plus VCC. Don't get confused with this power supply pins as this one. These are the input terminals. This is a power supply terminals, minus VEE. I can call it as. So inside the op-amp circuitry, there is a input resistance. I call it as Ri. And here, this is called as R0. This is the output resistance. This is what is called as the, you can also call it as input resistance or the input impedance. For simplicity, I call this as input resistance and output resistance. And let us say that it has got a gain. What are we using this op-amp for? For the amplification purpose. Whatever the input voltage you give, it must be amplified to a certain extent and give the output voltage. I can call it as A. Just to distinguish between the so many gains, closed loop gain, open loop gain. See, there is no connection between the output to the input. You can call it this kind of circuitry which is open. So it can call it as open loop gain. The first and foremost thing is that infinite input resistance. This Ri is infinity. So it is input impedance is so high, because of that the input current is zero. Input current I1, I call it as I2 is equal to 0. So the input resistance is high here. The second one or not. What is the output resistance? It is 0, just right opposite to that of the input. That means, what do you mean by input resistance is high? That means it will not load the source. That is what actually in the real world we want it. It should not load the source. For example, if you switch on one light, all other rooms' light should not get dimmed, because the one room light should not consume the current from all the room lights. So, so it should not take more, or I would say it should not load the source. The second one is that the output resistance zero. That means to say that it can provide more current to the load. So that serves the purpose. So can it be completely keep giving the source? No, everything has got a limitations in the practical amplifiers. Now we can talk about the open loop op amp gain. What is open loop gain? How it becomes infinite? If you consider this is the signal between the V1 and V2 is nothing but equal to the input voltage. That is the difference voltage or VDE. So the VDE is the output voltage is always equal to the some amplified version. There is a constant gain into VD, the difference voltage. This VD into AOL is nothing but your V naught. So fine. If that is the case, what is A with this formula? It is nothing but VD. Think about this actually. V naught is equal to what is VD? VD is nothing but your difference of this voltage, V1 minus V2. If this voltage becomes zero, then amplification will become infinity. So that means when V1 is equal to V2, it becomes zero, the difference voltage will become zero, the amplification will become infinity. It will not happen in the real world. There is always a difference of voltage which will tries to amplify to the maximum extent. So since there is no feedback to this op amp, I call it as open loop gain, which is equal to infinity. Okay. So it has got the one more, it is infinite bandwidth. So bandwidth is infinite. What do you mean by that bandwidth infinite? It is, it can allow all the frequencies to pass through without any kind of a distortion. Will that happen in practically? It will not happen in practically. It will have a distortion at the output. The gain will come down at higher frequencies because there are a lot of internal parameters which is not ideal as we think. So normally the gain will come down. So with this actually basic background, we can move on to the different circuit designs in the next episodes. Thank you so much for your attention.